Thanks for watching this video. I have a quick tutorial on how to take these Anderson Powerpole distribution blocks and modify them for use in a 48 volt system. I bought these on Amazon and they come, I think they're rated for 12 and 24 volts. The problem I've seen is that the resistors in here are not going to be the right resistors if you're going to use it as a higher voltage, 48 volts, and so we need to change the resistor. And then also in our system, we're going to have a 24 volt version of this, and then we're going to have a 48. And so I wanted to have a different color of the Anderson power poles for the 48 volt version, just so it's not confusing once it's installed and in service. Basically, you'll see like this here. This is actually an unmodified version. I've got it labeled for 24 volts, and then this one here I'm still working on, but this is going to be the 48. It's going to have yellow connectors on it and be labeled 48 volts. So once it's installed, users can see which voltage is going to be on which distribution block, and it's less confusing. So this video today, I'm going to walk through and modify a factory stock unit like this to be a 48 volt compatible version. The way these work is that there is an input and 8 output connectors. Sorry, off camera there. There's an input and eight output connectors, 15, 30, 45 amp Anderson Powerpole connectors, and then fuse holders for each of the input and outputs. There are LED lights as well. So each of these Anderson Powerpole fuse banks, if you will, has a red LED to show you when the fuse is blown. And then over here on the side is a, I think it's green, if I'm not mistaken, input power LED. So if there's any power on the bus, this will turn green to let you know. So for the 48 volt system, we're going to have to change the resistor that powers the green LED, and then we're actually going to take the red LEDs out of service. We're going to cut the resistors out just because I didn't do the math. I don't have the calculations and the right parts for those to work. I also don't need them in our application. So, but I do want to have this one here showing when there is power on the bus. So we're gonna change that, and again, we're going to change the connectors so they're yellow. So first thing I'll do here is open this thing up. And push the lid off, and that's the lid. Then we have in here fuse holders. We have some LED lights, some resistors, of course the Anderson power poles. There's 6 screws holding this onto the base, so we're going to go ahead and pull those off here. Something that's nice about these power distribution blocks is that there are not fine electronics on here. It's just a couple coarse, discrete components that are tolerable to abuse. So you don't have to be necessarily particularly gentle with these electronics. You're not going to kill them with static electricity, or you can kill them with a tool, I guess, but it's not fine electronics, which is definitely nice. So 6 screws here. Okay, and then the base, I'm going to set that aside for now. So what we're left with is this distribution block and the circuit board. And then the back side, of course, there's various wiring and whatnot. And we are going to need a soldering iron for the work today. So that's that. The first thing I'm going to do is work on these LEDs, and then we'll come back and change the Anderson power poles to yellow. I'm going to pause the video for a second here so I can grab my soldering iron. Okay, so I have this here workbench vise from Harbor Freight. I like to use this to hold my work. And before I get started here, just to show you what we're going to do, again, this is the power input LED, or rather, you know, if there's power on the bus at all, this one turns on. These are the output LED fuse broken indicators that we don't need for this installation. So each LED has a resistor next to it. These are going to get broken and pulled off. We don't need them. This one down here is the one we're going to swap out for a different size. So I'm going to start with pulling out these 8 resistors here. There's a few ways to do this. On a prior version of this board, I just took some needle nose pliers and just broke off the resistors. It worked just fine. Since I have the soldering iron out, I'm just going to see if I can't desolder them and get them out cleanly. Let's see here. So since I don't need these parts, I'm just using a set of needle nose pliers to grab on and then give it a tug. There's one. And I am pulling these off because, again, they're the wrong resistance for a 48 volt system, and I could create some smoke if I try to do things, or at least burn out LEDs and whatnot. Since I'm in here, it makes sense just to pull them off instead of letting them burn up. That's number 3. That's number 4. Looks like on 2 of these here, I didn't get all the terminal off. I actually broke the resistor, so I'll have to come back and clean that up. I'll show you that in a second. See if this will work. I'm right-handed, so soldering left-handed is going to be a trick. It works. Come on. All right. The last one is this one over here. Kind of feel like I'm just mutilating this board, but it's okay, because again, I can be kind of rough with this one, this particular design, and these are pieces I don't need. If I was trying to do something more sensitive, I would obviously have to be a lot more gentle with the components. Okay, so I need to go back and clean up a couple of these. So just to see if I can show you here, there's a couple of these resistor legs. I'm not sure how well you can see it on the camera there, but there's part of the resistor is still stuck in the terminals, or still stuck on the board. It looks like actually it's just the one on this one. So I got to pull that leg off real quick, just so it doesn't inadvertently short something out in the future. Well, it is what it is. I'm going to go ahead and pull off this resistor here. This is going to be the, well, I'll show you where I'm at. I've got all 8 of the red resistors for the red fused LED situations go off. This last one is the one for the always on if there's power situation. I'm pulling that off, and I'm going to put a new resistor in its place. Now the resistor that goes in its place is going to be one of these. Let's see. You can kind of get a read on it there. Camera's not the best, but that's the part number. Just to read it out here, it's 4CT52R243JCT. All right. I could try to clean up these holes and thread it back and install it the way it was in the board, but I'm being a little lazy on these, and which I think is okay for this application. I am simply going to trim these and stick it on the back of the board. Works good enough for what I'm trying to accomplish today. Okay, so I've got a resistor with basically very short legs. Gonna grab that guy here. A little bit of solder. I created a solder bridge here when I was cleaning up the other component. Try to get rid of that. There we go. Okay, one leg on. Push that down. Get the other leg on there. And I just dropped the resistor right out the front of it because I was heating up the pad. I got too much solder on there. I was trying to rub that off and drop the resistor right out of there. So that's not good, especially since the resistors are sensitive to polarity. So I'm gonna pause the video here, go look at my other board, and come back so I can install that diode. I think I said resistor, but the LED is what I dropped out. I'll be right back. Okay, so I'm gonna clean this up, get some of the solder out of here so I can hopefully put that right back in the same hole. This is solder wick, so it's gonna clean off and suck out solder to get it off the board, and then I'll put some more back on as I get ready. So what I'm doing here is just trying to heat the pads up, push the LED through, and there we go. That soldered it right on. Sometimes you have to put a lot of solder on the back just to thoroughly heat everything up, push the component through, and then clean it up afterwards, but I got kind of lucky on that one. I'm going to put a little bit of solder back on this resistor to make sure it's in good contact, and then we are done. Yep, that's it. that's it for the components at least. So soldering iron off. What are we left with here? We have I gotta bend these. Sorry, I'm all over the place as far as what to do on this. I didn't script this video. So I've removed the resistors for the 8 fuse blown indicators. We therefore are not going to use these, so I'm going to take them. I could kind of force and bend them forward, which is what I've done in the past. I can also just clip them off. These ones are a little bit firm the way they have them set up, so I'm just going to pull those resistors out of there. Oh, sorry, those diodes out of there, LEDs. And then we'll come back and review the rest of the board. I don't want to leave them there because then they're confusing. You know, when you look at the finished product and people are like, hey, this isn't working, or I think it's fine, or I think it's not, or whatever, based on that. I'd rather there just be a hole in the case where they know there's no LED to confuse. So I'm having a hard time removing that component. I'm going to put a little solder on my soldering iron. Oh, I turned it off too. I did tell you guys I turned that off. Leave your soldering iron on. It helps. You're going to come back and do more work. But I'm going to put more solder on it so I can create a thermal bond easier between me and the component that I'm working on. Here's one. I'm going to have to come back and clean up my solder too because I don't want to leave a solder bridge across any of these. See, with a little solder on the tip, it makes that go a lot faster. Just like that. One more. Okay. Now, see what I have here? No LEDs and no resistors for those LEDs. I'm going to clean up the solder just to make sure there's no bridges where there shouldn't be. Those look fine, those look fine. Okay, good enough for what we're doing. I'm going to go ahead and throw all these LEDs and resistors away. Clean up my workspace. Those are gone. So we are pretty far along now. What I'm left with is a 48 volt ready unit. No LEDs for the fuse blown detection system. There's no resistors for each of those LEDs. So those are kind of cleared off. We do have the LED for the system voltage with a new resistor there. The only thing remaining is to test it and of course to change out the red for yellow Anderson Powerpole connectors. Before I proceed, I want to make sure that what I'm doing is working or will work, and in order to do that I need to test, and in this case I need a 48 volt power supply that I can use to power this thing up and make sure that it doesn't blow up, it doesn't do the wrong thing. So stand by while I grab one of those. Okay, so I'm back with a power supply. Go ahead and turn off my soldering iron here. Move it over this way so it can cool down on its own. This is a Meanwell AC in, 48 out power supply. And then I have to go with it here a, let's see, what am I going to use? Yeah, so I'm just going to use this, a small sample test cable thing. It will work just fine. So all this is just a cable that I have sitting down here with an Anderson Powerpole already crimped onto it, and wire leads sticking out. So good enough for me to hook into my power supply for today. I think something worth mentioning here is I am aware these are red, and again in our system we're trying to use yellow for 48 volts. This is not something I will leave, it's just for testing today. So functionally this will work, but if I were going to leave this as 48 volts powered through this cable, this would need to be yellow. My cable's a little bit short here, so the power supply is going to be a little out of frame. So I don't want to plug this in with this metal shorting out, so I'll take this, stick it in the tray here, and then power it up. And I get myself an LED. So that turned on. That tells me that the 48 volts is not blowing it out. Let's test and make sure we're actually using 48 volts. I know we are, but this little guy here will tell us what we got going on. If I put a fuse in it. One sec. So this here shows we're at 48.44 volts. 2.6 watts to run this guy. So we're at 48 volts. This is running great. Power is doing what we want it to do. LEDs are doing what we want it to do. Let's go ahead and get these things changed out so they're no longer red and they are indeed yellow. And then we can put the cover on and move along. I make it sound easy. Unfortunately, removing these is not that easy. There is a trick to it. There's a little, it's kind of, I'm not going to be able to show it to you on the camera here, but there's a little pin inside here in each one of these Anderson power poles that you can use a really fine screwdriver, flathead, to get in, get under, and you know, get it to release. So I'm going to go ahead and do that. Also, the black one needs to be removed first, and then the red one, which is unfortunate because we only really need the red one off there, but that's what it is. So the release pin there, get that to pull up, and then this guy can be pulled off the rest of the way. Okay, so with that, I've removed all 16 of the Anderson Powerpole connector covers, and as you can see here, we're left with a board that has a bunch of Anderson Powerpole terminals, and it's ready for the terminals to be put back on. Now, it's pretty important that when you put them together, you don't reverse the colors and you put them in the black back where it was. So here's a good board, and this kind of shows what we're going for. I'm going to get my Anderson Powerpoles here. I have a bag of yellow in this case. So yellow goes on first, and then the black goes on. It's kind of in reverse order of what we had before. And the Anderson Powerpole needs to match the direction of the tongue on the connector on the board. So just like that. So that will match where the red was before. These, once you push them down, they just lock in place. The tongue catches that spring clip in the connector. Okay, so we've got all the yellow ones done. We'll put these same black ones back. They're reusable. They're just slightly scratched up from the process. Let's see if you can see it on camera here. Yeah, slightly scratched up there from the process of using the pliers, but functionally they're just fine. If for some reason they cracked, then I would just pull them off, or put new ones in their place. Something to keep in mind if you find yourself doing this project is that there's tongue and grooves. So the tongue is on this side of the yellow connector, and there's a groove, a socket if you will, right here on this black one. So not only are we going to put this connector on, but we need to make sure the tongue and groove engages as well. So you don't want these things sitting apart like this. You want to have them tongue and groove engaged like so. So that way they're tight together. And then they'll mate well with the mating connectors. Just like that, we did it. All right, so we're gonna put this back together. Grab the base. Base goes there. I do recommend using a magnetic screwdriver. Unfortunately, I don't have one for this. and then the cover. That's our input. That's our input. Not like it'll fit the other way anyway, but there we go. All right, and that is nearly a finished product. So a 48 volt Anderson Powerpole distribution block. The next step would be